This is lesson 3.6, transformations of graphs of linear functions. You should be on page 146 of your textbook. In this lesson, you're going to learn the following things. You're going to learn how to translate and reflect graphs of linear functions. You're going to learn how to stretch and shrink graphs of linear functions. And you're going to learn how to combine transformations of graphs of linear functions. So first of all, let's get some basics out of the way. A family of functions, it says here, is a group of functions with similar characteristics. So here would be an example. Like if you think about a line, an equation for a line, like this would be a equation of a line in slope-intercept form. If I wrote another equation of a line in slope-intercept form, these would be part of the same family. They're both equations in slope-intercept form. So when you see a family of functions as a group of functions with similar characteristics, any equation in slope-intercept form would be part of a family. Okay? This next term is important. Parent function. The most basic function in a family of functions called the parent function. So the parent is the most basic function in that family. So if you think about a family of slope-intercept form equations, the most basic one I can think of would be this. Y equals x would be the most basic because it has a slope of 1 and a y-intercept of 0. This would be the parent function of the family of equations in slope-intercept form. Okay, so that's what a parent function is the most basic. And that's what they say here. For non-consistent linear functions, that sounds complicated, the parent function is f of x equals x. In other words, the most basic function in the family of slope-intercept form equations would be y equals x, which I could also write as f of x equals x in function notation. Okay? This word, very important. A transformation is going to change the size, shape, position, or orientation of a graph. So if I have a graph on paper and I do something to change that graph, if I want to change its size or its shape, its position, or orientation might be like I flip it over or I reflect it from top down. That's considered a transformation. A transformation is when I'm changing the size, shape, position, or orientation of the graph. Now, you're going to learn basically three major kinds of transformations in this lesson. One's a translation. Okay, if I turn the page here, you're going to learn about reflections. And if I go from there, you're going to learn about what's called stretching and shrinking. Okay, and I put a little summary here on the back, and you can get this in your notes. Okay, so again, a transformation is a general word that means I'm changing the graph somehow. I'm changing the size, shape, position, or orientation. Here are the kinds of transformations you're going to learn in this video. A translation is sliding the graph to a new position. Okay, so if I just take a line and slide it to a new position on my graph, I've translated it. A reflection is if I take my line and flip it over a line of reflection. It's going to be easier to show you that, but you know, if you flip something over, you've reflected it. Or I could stretch or shrink my graph. That would be pulling the graph toward or from an axis. So you might be like, what does that mean to pull the graph toward or from an axis? It means I'm steepening or lessening the angle of incline of my line. So again, I'll be able to show you this here in a minute. Okay? So let's talk about a translation. Again, a translation, it says, is a transformation that shifts the graph horizontally or vertically, but does not change the size, shape, or orientation. So that, again, that sounds kind of wordy. You know, mathematicians, they can be wordy and it sounds complicated. Here's all that's telling you. You are sliding the graph to a new position. Okay? So if you slide the graph to a new position, you have translated it. Okay, now one thing I want to show you, which is going to be a huge help in understanding this, is and you'll be able to use this on quizzes and tests, we're going to use the Desmos graphing calculator. So I'm going to show you where you can get that. You can get that by just typing in Desmos graphing in Google. You go to graphing calculator, and this is going to be really cool. It's going to allow you to type equations in and see how these translations take place, okay? So what you see here, this looks very complex, so I think it's going to be easier. Instead of me trying to read through this and show you this, I think we can just do a couple of examples and type it into Desmos, and you'll see that this becomes pretty easy. Okay, so let's say we had a line f of x equals 2x minus 1. So I go to my calculator here, and I'm going to type this in, f of x equals 2x minus 1. Okay, and you'll see that they even graphed the line for me on Desmos, and I'm just going to change this. So yeah, I'm just going to blow this up a little bit. Okay, now what they want us to do is they want us, that's right now for this problem, this is the base function, f of x equals 2x minus 2. They now want us to graph a new function, g of x equals f of x plus 3. Okay, so let's just type that in with my new equation here, g of x equals f of x plus 3. And I want you to watch what happens here when this new equation gets typed in. Do you notice how this new line is, let's count, it's 1, 2, 3 units higher than this original line, f of x equals 2x minus 1. Now I better point out this line here that I'm highlighting is in red on Desmos, and this line is in blue. Okay, you see how this line has been moved up 3 units. Now look at the equation. How could I tell that this would have been 3 units higher? Well, if you look at the equation carefully, do you see this plus 3 kind of like outside of f of x? This is saying that this new line g of x is taking the old line f of x and moving it up 3. That's all that's saying. Okay? So that's what this right here is trying to tell you. When you see this plus k, like we're adding or subtracting something outside the function, it's going to translate your graph up or down depending on if you're adding or subtracting. Okay? Now, look here. Let's type this one in. We have a t of x equals f of x plus 3. Now, you might be like, that's the same thing as this, what we just did. Well, no, it's not. You see how the plus 3 here is outside, where the plus 3 here is inside. Let's type this one in. T of x equals f of x plus 3. So I'm going to make a new one here. T of x equals f of x plus 3. This will be in green. Okay, now, you see this green line, it moved, it looks like, I'm counting here, it looks like it moved 1, 2, 3 units to the left. And it did, it moved 3 units to the left. Now you might be like, well, wait a minute, that doesn't make sense. It says plus 3 inside. Why wouldn't it move 3 to the right? When you have a function and we're doing these transformations of any kind, when you see inside means we are affecting the graph horizontally. So this plus 3 is inside the function. That's affecting it horizontally. For some reason, I don't know, have a better way to explain it than this. When it's inside, it's always going to be backwards from what it seems. When it says plus 3, you'd think 3 right. It actually means 3 left. Outside, it's normal. If you add 3, I'm just moving it up 3. Now, here's the cool thing. If you're not sure, you can just type it into Desmos, and you look at the picture, and it will tell you. Okay, so that's why, and Desmos is not cheating, by the way. The PSAT, the SAT, Desmos is an application that you can use on these. Okay, so there's nothing cheating about you using Desmos and just checking, hey, here's my parent, when I type that in and then I type in this, what's happening, and describe it. Because that's what this lesson is about. You telling me what transformation took place. Okay, so there would be, anyway, that'd be a translation. Let's now look at reflection. So let me turn the page. Let's talk about reflection. A reflection is going to flip the graph over a line called the line of reflection. Normally, the line of reflection is either going to be the y-axis if you're doing a horizontal reflection, or, well, actually I have this backwards. Here's the y-axis. If I flip over the y-axis, that's a horizontal reflection. If I flip over the x-axis like this picture, that's going to be a vertical reflection. Okay, so let's try it with this here. So let's just type this in and see what happens. So I'm going to say that f of x is half x plus 1. So let's go back to Desmos and type that in, and let me get these out of here. We're going to start from scratch. So we said f of x is half x plus 1. Let me type that in. And half, you guys know I like using parentheses around these just to make sure, x plus 1. Okay, so there's my function. You can see this line. It has a y-intercept of 1, and my slope is up 1 over 2 each time. Okay, now the transformation taking place is we have g of x equals negative f of x. So let's type that one in and see what happens. What does this new function going to do to the old one? G of x equals negative f of x. You notice this flipped, this reflection occurred over the x-axis. Like this point here flipped down to here. It flipped over the x-axis. And this point here flipped up to here. It flipped over the x-axis. So this would be a vertical reflection. Now, how could I look at this statement and know it's vertical? Well, you notice how the negative is outside. Remember how before, when we had the plus 3 outside, it moved my graph up or down vertically, or vertically it was outside. Same thing here. If the negative's outside, it's going to flip my graph, reflect it vertically. Okay? So what happens if the negative is on the inside? Okay, I hope that you're starting to pick up, wait a minute, if it's inside, it should be a horizontal reflection. So let's type this one in. T of x equals, let's do it, T of x equals f of negative x, and let's see, is this horizontal? And yeah, I am getting a horizontal reflection now, because here was the original line in purple. Look at this point right here in purple. You notice how if I take this point, which is 2 units away from the y-axis, the reflecting point is on the other side 2 units away. So yeah, it flipped from right to left. It flipped horizontally over the y-axis. Okay, and how can I tell by looking at the statement? Well, there's a negative inside. I know it's got to be a horizontal reflection. Okay, let's keep going, and let's go over stretching and shrinking. Okay, you can have horizontal stretches and shrinks, and you can have vertical stretches and shrinks. I hope you're picking up that if it's horizontal, when I look at my statement, there's going to be something in the function, inside of it, like here, like you see here, this is inside that 1/3. That would be doing some kind of stretching or shrinking horizontally. But like here, when there's a 3 outside, that's going to stretch or shrink my graph vertically. Let's try this, because again, if I could read through this, and you might be like, that looks kind of complicated. It's not complicated. It's just telling you exactly what I'm telling you here. Let's type this in and see what happens. So let's do f of x equals x minus 1. Type it in. Okay, so here is that base function for this problem, and it's a line, that has a y-intercept of -1 and a slope of 1. Okay, and I tell you what, we're going to do this one first actually. H of x equals 3 times f of x. Let's see what happens here. So we said, I said h of x, right? Yep, h of x, oops, shoot, not typing good here, equals 3 times f of x. Okay, look at what happened here. Okay, you notice my original line, had a slope of 1. It was going up 1, right 1, up 1, right 1. But now look at this new line. This new line is going up 3, right 1. So let me say that again. My original line had a slope of 1. This line has a slope of 3. Do you notice how this is so much steeper? Okay, the proper terminology is this graph, h of x equals 3f of x. This is a vertical stretch of the function f of x. This is being stretched by a factor of 3. You can see it. The slope of this line in green is a slope of 3. The slope of the graph in blue is a slope of 1. Okay, now, and you notice it's vertical. The 3 was outside. Okay, let's go and try this one. It says g of x equals f times 1/3 x. Let's try that. G of x equals f times 1/3 x. I am going to just type the 1/3. I think I can do this. Okay. Okay, now this is in purple. So we're going to compare the blue line to the purple line. Okay, do you notice that this purple line, when we think horizontally, all right, so I'm looking at points on this blue line. You notice how the purple line, like let's take this point here. The purple line is 3 times farther away from the y-axis than this corresponding point on the blue line. This purple line is being horizontally stretched by a factor of 3. Now you might be like, wait a minute, Mr. Lemansky, this line has a lesser slope. You're right if I'm looking up and down. But if I'm looking kind of sideways from left to right, this purple line is being stretched. Like this point is 3 times farther away from the y-axis than this corresponding point in blue. This would be a horizontal stretch. Remember how I said horizontally, when you have things, it's going to be backwards from what it says? 1/3 would make me think it's 1/3 as much. If you the kind of the reverse of that is 3 times as much. This point is 3 times farther away from the y-axis than its corresponding point from the original line. Okay, so anyway, that kind of gives you a summary of how we can use Desmos to help us answer these questions, okay? So we can stretch graphs. Let's do a shrink real quick just so you can see it. Like this would be a vertical shrink. Let me type this one up. F of x equals, actually, I tell you what, we're just going to keep this in here. Let me just do a quick vertical shrink so you can see it. I'll call it g of x, and we'll do times 1/2, 1/2 x, f of x. And I want you to see what happens. The 1/2 is outside. Do you notice how this new line has a lesser slope because this graph has been vertically shrunk? The half is outside. That's a vertical effect. Anytime you see anything outside the function, it's affecting the graph vertically, okay? Anytime we see something inside, it's affecting the graph horizontally, all right? Let me see what else we have. You can combine transformations. We can practice that in the homework. I don't want to make the video super long on you. We'll talk about some real life problems in the homework. This you might, I'm not going to let the video play, but you could freeze the video. This, I've had see before Desmos, my classes just had to know this without the help of Desmos. So this is nice to know. It's going to help you. But anyway, this is kind of like a rule sheet so my kids could look at a statement, because that's what this whole lesson is about, is looking at a statement and telling what kind of transformation there is. So let's just do a couple quick problems together. I'm going to get out the book. I want to go to lesson 3.6 just so you can see, like on a homework problem, what's going on, so you can understand how you could use Desmos to answer these questions, because that's all this is. Okay, so like for example, let's look at the homework. And let's look at number 7. And it says, use the graphs of f and g to describe the transformation of the graph of f to the graph of g. So let's say that I didn't know what I was doing. Desmos would give me the answer to this. I can go to Desmos and type in f of x equals 1/3 x plus 3. Let's do that. Okay, so f of x equals 1/3 x plus 3. I guess I don't even need to use parentheses on this, because this will give me fractions, 1/3 x plus 3. Okay, so here's the original line, and it's in red. Okay, let's go back to the book. And they want to figure out, what is g doing to this line? What is this function g doing to the line? Well, it's taking f of x and subtracting 3. Now, what I'd like you to actually figure out or be able to do is, I'm hoping that you can read this and say, wait a minute, the -3 is outside. Outside means vertical. When I graph this on Desmos, which I'm going to do in a minute, this line should be 3 units below the one that I typed in already. That's what this is telling me. F of x minus 3 would be g of x. G of x is taking this line and moving it down 3. Let me type that in. Okay, so g of x equals f of x minus 3. And you notice the blue line is 3 units, or 3, it's been translated down 3 units, so that's what I would write for the answer for 7. G of x is a vertical translation 3 units down from f of x, okay? I wanted to make this video shorter. I think I've accomplished that. As I told you guys in class, I think 15 minutes is optimal. I don't know how long this is, but I think it's a lot less than the 28 minutes that my original video was on this. So if you have questions, make sure you ask in class. We'll do some together. But if you can use Desmos, Desmos could help answer a lot of these even if you weren't sure. So that's why I wanted to introduce you to Desmos. I'm going to stop the video here. If you had questions, please make sure you ask in class.